Welcome, folks. I'm just trying to grab some lunch. We will get started in about 3 minutes. Big thanks to whoever liked the video of me eating. Welcome, folks. We'll get started in about 1 minute. All right. Welcome, folks. It's 1 p.m. and we're going to get started. So, welcome to the 24th day of remote learning. I had a really good joke about protests in my collection, but I don't feel like joking about protests today. If you've been following the news, you know that there are a number of things going on in the United States and in Canada that are very concerning, but unfortunately not very unusual. So I just wanted to let you know tonight at 5 p.m. there's a rally in Victoria Park in solidarity with people protesting the killing of Floyd George and many others. If you're concerned about the issue and want to attend, please wear a mask and keep a 2 meter distance. We want this to be a statement of a political nature and not a chance for people to get sick. So, if you're interested in the topic, please, do things carefully. A number of us from the Cameron community will be there. All right, so on to today's lesson. We're talking about what happens when we change the length of certain dimensions of a shape. So, for example, what happens when we change the length of a rectangle or the width of a rectangle? What happens when we change the radius of a circle? And we may even be able to get into three-dimensional shapes depending on how much time we have. So that's our plan for today. Let's get started. There we go. Oh, rotate. There we go. All right. homework is long. Is there a due date on it? No, there is no due date on it. Hopefully, as you go, Jackson, you'll see that even though there are quite a few questions, that they should be pretty short. Okay, so varying lengths. See if I can spell varying correctly. Cool. Okay, so if you head into the classroom, we're looking at handout 2.18.h, changing lengths effects on measurement. So there's a few parts of grade 9 that I find are often useful in real life, like just casual situations in real life. This is one of them. I'll give you an example of a few others. So, for example, in science class, being able to understand heat transfer is something that I often see people and they kind of learn stuff in science class and then they don't think about it when they're going about their daily lives. So, I've often been cooking something with friends and we have to boil a pot of water, say to make some rice or some pasta. And my friend puts the pot on the stove and turns it on to high and doesn't cover the pot. And I'm always like, wait, what? Why aren't you covering the pot? And they're like, oh, well, I think maybe it boils faster. I don't really know. I was like, no, 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 no. Like, you want to accumulate as much heat in the pot as you can. Putting a cover on the pot is going to trap the heat in. That's basic grade 9 science. But people don't think about these things in their daily lives. So the changing or the effect of changing lengths on measurement is another one that happens that way. A lot of times I'll see people with two different containers and they know something about the first container, perhaps its volume, and they're trying to estimate the volume of the second container from the first container. And because they don't understand varying lengths, they're not able to make a good estimate. So our goal here is to help you to be able to estimate volumes and so on a lot more easily in your life. And so, whether you are building something in your backyard, or you're doing a major construction project, or you're baking, or whatever it is, that you're in a position where you can quickly make relatively accurate estimates of volumes based on the principles that we learned today. Okay. So, if we look at the handout, the very first question, draw a rectangle and label it with a length and width of your choice. So go ahead and do that and choose whatever length and width you want. Can be whole numbers, can be decimals, anything you'd like. Once you have a length and a width and you've drawn your diagram, go ahead and just type into chat what length and width you want or you've chosen. So I'll put mine in here. I chose 6.29 by 5. Great question, Alan. You're welcome to do this right in the document. That's probably the easiest way. We're not going to have to do a lot of symbols or anything that would be hard to type into the document. So probably the easiest thing for you is to just make a copy of the document and type directly into the document, and then it'll be easy for the homework. So please let me know in the chat once you've picked a length and a width. just type them in like I did here, 6.29 times 5. So that tells me that the width is 6.29, the length is 5. Thank you, Owen. Let's see if we can get at least 3 or 4 of them in chat before we move on. I want to make sure that everyone has time to actually try this. Thank you, Alan. Thank you, Nina. All right, so once you have your length and width picked, go ahead and calculate the area of your rectangle. And once you have an answer, go right ahead and put it in chat. And for today's work, please, basically just as soon as you get an answer to each step, just go ahead and type it into the chat. We'll try and keep that up, make it a little more participatory than we usually have. So I multiplied them. I got 31.42. 45, sorry. Jackson, cool. Thank you, Owen. Let's see if we can get one more before. Cool, thank you, Adam. Okay, question 3 asks, double the length, what happens to the area? And before you actually do the calculation, I'm going to ask you to take a guess in your head. What do you think, how do you think the area is going to change if you double just the length? So the width doesn't change, you just double the length. What's going to happen to the area? Once you have a guess in your head, go ahead and do the calculation. Thank you, Jackson. Got a prediction and an answer, and your answer looks like it matches your prediction. So folks, once you get the new area, go ahead, type it into the chat. In my case, I have 62.9. Owen got 100. Cool. Well, let's get one more in there. Thank you, Alan, 126. All right, so Jackson has given us a hypothesis here that the area is going to double. And for his rectangle, it did. It went from 20 to 40. Owen's went from 50 to 100, also a doubling. Mine went from 31.45 to 62.9, also a doubling. And Alan's also went from 63 to 126, also a doubling. So we're seeing that the data is consistent with Jackson's hypothesis that the area is going to double. All right, so question 3, let's write that in. The area doubled. And if you didn't get an area that doubled, please let me know in the chat and we'll work through it and see what's going on. Okay. So we're actually going to skip question 4 for now. So you can type skip in there. We'll come back to it in a few minutes. All right. Instead, we're going to move on to question 5. So go ahead and draw a triangle, label it with a base and height of your choice. So 4, skip for now. I'll leave a bit of space and we'll come back. Question 5, draw a triangle. and label it with a base and a height of your choice. And then question 6 asks you to calculate the area. Great question, Jackson. You don't need to draw it. You can just type in what the base and the height is. That's totally reasonable. Okay. So question 6 is to find the area, which is base times height divided by 2 because it's a triangle. Okay, and so once you have questions 5 and 6, please go ahead and type them into the chat. And you can put it all together in one line. So like mine, I have 3 as my base times 4 as my width divided by 2 equals 6 for my area. Thank you, Owen. Thank you, Alan. Looks good, Alan. Thank you, Jackson. All right, let's look at question 7. It asks, what do you think will happen if you double the height? Check your guess. So make up your mind what you think is going to happen and then try it out. Double the height, calculate the new area, and put your answer up in the chat. All right, so folks are saying area is going to double. We get Jackson's triangle went from 14 to 28, so it did indeed double. Owen's went from 60 to 120, so it did indeed double as well. And what I found with mine is also that we got a doubling, 6 centimeters to 12 centimeters. All right. So we're going to skip question 8. Excuse me. We will come back to it as well. And we'll look at question 9. So leaving a bit of space here for 8. And then question 9. Question 9, we're asked to draw a circle. Label it with a radius of your choice, any radius you want. And then go ahead and calculate the area, which is question 10. So Alan also got a doubling for the triangle from 33 to 66. Jackson's got an area of 28.27 for his circle. Owen's is 314. Owen, I think I can guess your radius. All right. So I'll give you a second to make sure you're caught up. Please do try this one out. Pick a circle, choose your own radius, calculate the area. Formula for circular area is pi r squared. And then we're looking at question 11. What do you think will happen if you double the radius? Check your guess. So make a prediction. What's going to happen if we double the radius? And then go ahead and calculate what you should get. Thank you, Jackson. Thank you, Owen. All right. So we're seeing that this time the area didn't double. It actually quadrupled. You can see it with mine. I got 314 as my second one. So if I do 314 divided by 4, you can see 78.5. That gets me to my first one. So this one times 4 gets me up to 314. Owen started at 314, had a quadrupling. Jackson started at 28.27. His quadrupled. So my question for you, and this is like the key to understanding what's going on for this whole lesson. Why did it quadruple instead of double? So take a moment, think about it. Throw out any ideas you have in chat. You don't need to be confident that they're correct. Just throw some ideas out there. Why is it that when we change the radius of a circle to twice its length, we get a quadrupling in the area, but when we change the height of a triangle, we only get a doubling? All right. So Owen has one hypothesis, saying because we square the radius. Cool. Any other ideas? All right. So it does indeed have something to do with this squaring. And so Owen's response is correct. I want to take a look a little bit deeper into what the meaning is of that squaring and why that's going to create a quadrupling rather than a doubling. So I'm going to draw here on some grid paper. I have a rectangle. It is 2 squares by 3 squares. I don't know how well you can see the grid there. Hopefully you can see it at least a little bit. If I double the width of this rectangle. Now it's going to be 2 squares by 6 squares. And you can see if I draw a little dotted line there, it splits it into 2 rectangles that are the same size as the original. Notice that when I double the width, the height of the rectangle doesn't change. And if we look at the area formula, we have length times width. Each of these things has an invisible power of 1 that we basically ignore because most of the time it's not important. If, on the other hand, I take a circle, and I'm going to go with a circle here, I'm going to try and do circle of radius 1, just to make it a little easier to draw accurately. So 1 square out is the radius of the circle. If I go to a circle of radius 2, is this an accurate drawing of what happens? Or a close to accurate drawing of what happens? I stretch out my radius to 2. Not really, right? When you change a circle's radius, yeah, thank you. So when I change a circle's radius, it doesn't just change the width of the circle. If I want to go to a circle of radius 2, I'm going to try to draw this accurately or somewhat accurately. I'm going to get something like this. So as Jackson says, the whole circle is going to expand. The width of the circle is going to double, and the height of the circle is going to double. So changing the radius of a circle doesn't just change its distance in one dimension, it changes it in 2 different dimensions. And the area formula for a circle, r squared, just means r times r. And so this is kind of like saying 1 r for the width and a second r for the height, because the radius of the circle affects both of those dimensions. And so that's why we have a pi r squared. The r gets squared in the formula because it's having 2 dimensions of effect. It's affecting width and length, or it's affecting width and height, depending on how you want to think about it. So this has some big implications for what we're doing, because it's going to be true not only for area, but also for volume. It actually turns out that perimeter of all things is the one where it's complicated. For area and for volume, if one dimension doubles, then the area or volume is going to double. If a radius doubles in a circle, that's 2 dimensions that have doubled. So we're going to multiply by 2 twice, times 2 times 2, which makes times 4. If we had a sphere and we doubled the radius, that would make 3 dimensions that would double, because the sphere would get wider, it would get taller, and it would get deeper front to back. So if we double the radius of a sphere, we're going to multiply by 2 for the width, by 2 for the height, and by 2 for the depth. 2 times 2 times 2 is 8. So the volume of a sphere is going to get 8 times as big when the radius doubles. And so it's this idea that whatever we multiply one dimension by, that's the change we're going to see in the area or in the radius. But if we're changing something that affects multiple dimensions, then we have to multiply multiple times. Here we're multiplying by 2 twice, once for the width, once for the height. What questions do you have about that? So I'll give you 30 seconds to put some questions into the chat. This is really the key idea. Like, once we understand this, everything else is not, I wouldn't say super easy, but definitely much easier. And the explanations kind of make sense. This is the crux of it. So here's the time when you really want to ask some questions. So I'll give you about 20 seconds to write down any questions. And if you're feeling like, yeah, that totally makes sense, I'm good to go, you can let me know that in the chat as well. Okay, so give me a 1 in the chat if that's making sense to you and you're ready to go back and try a couple of the questions that we skipped. Thanks, Jackson. Thanks, Alan. Okay, so I'll keep watching the chat. If you have questions, please put them in there. Let's go back. We skipped question 4. From the original rectangle, we want to quadruple the length, and we want to make the width 1/4 of its initial value. In other words, we want to multiply it by 1/4. What happens to the area? Well, one way to think about it is that the new area is length, which is the old length times 4, times width, which is the old width times 1/4. Sorry, just going to make sure I'm on camera here. Length will stay the same. Good guess, Jackson. And so we know when we do a big multiplication, we can do it in any order we want. Well, 4 times 1/4 is 1. So we'll have 1 times L times W, or just LW, which is the old length times the old width. And that is going to give us the old area. So as Jackson says, lengths will stay the same, or the area will stay the same, basically the same thing, but with different numbers. All right. So there's a couple ways to think about this. So one way is by putting in the changes within the formula like I did there. Another way is to say the new area is going to be the old area times 4, because the length got 4 times as long, times 1/4 because the width got shortened down to 1/4 of its previous. And again, 4 times 1/4 is 1. So we get the old area. And you can, of course, actually do these calculations, right? You can take your length and multiply it by 4 and get the new length. You can take your width, divide it by 4, or multiply by 1/4, get your new width, and then calculate the new area that way, and you should get the old area. But here we're just seeing a faster way to think it through. Okay, well, if I quadruple the length, but I shrink the width down to 1/4, I know even without making all of those calculations that I should get the same area just because I times by 4 and then I times by 1/4. All right, let's see that again for question 8 here. If we triple the height and double the base of a triangle, so new height, maybe I'll do it like this, h new equals h old times 3. So the old height got tripled, and the base for the new one is going to be the old base times 2 because it doubled. So what's your prediction for how the area of this triangle is going to change? Go ahead and let me know in chat. What do you think we'll see as a change in the area of our triangle? Jackson's guessing tripled. Cool. All right, well, let's try it out. So Jackson's had the bravery to guess. Everyone else is being more cautious. Totally fair. So what is our new area? Well, it's going to be the old area, and then multiplying the height by 3 is going to multiply the whole area by 3 because the height affects one direction, one dimension. And so it's going to have just a regular straight up effect on the area that's the same, both times 3. And then the base is going to get multiplied by 2. And that is also going to double the area. So 3 times 2 is 6. So we can take the old area times 6. And that's what we would expect. So Jackson, if it was just the height changing, you're absolutely right that we would get a tripling. But we're also getting this change in the base, that it's getting twice as wide. Okay. So please go ahead and check this out. Take your original triangle. I'm going to do it here. My original height was 4. My new height is going to be 4 tripled, which is 12. My old base was 3. So my new base is going to be 3 doubled, which is 6. And so my new area is going to be 12 times 6 divided by 2, and that is 36. And you can see that 36 centimeters squared is indeed 6 times as big as the original area. So you can see things start to get complicated when you get more than one dimension changing, but we can start to think about what's going on. One way that some people like to think about this is like a big stack of boxes. That if you double the width of a stack of boxes, you've basically doubled how many boxes are in the stack. And then if you triple the height, you've now tripled the number of boxes in this new stack. So you doubled, then tripled, times 6 in total. So give me a 1 in the chat if that's making sense. And if you have questions, now is a great time to ask them. All right, so I'm not sure if I've lost folks or we've missed the connection here. What questions do you have about what happened when we took this triangle and we tripled the height, we doubled the base, and how we got an area that was 6 times as big? In other words, times 3 times 2, 6 times as big. Okay, thanks for letting me know, Jackson. I'm going to look back and see. I think you told me about your triangle there. 4 base. So Jackson, your triangle had an area of 14. And when you doubled it, you got 28. So I'm going to guess that your, and this might be wrong, I'm just guessing, that you had a triangle that was like 7 high by 2 wide. Maybe you did it the other way around. There's a few other options as well. This is one possible guess. So assuming this is 7 high, 2 wide, then the new height is going to be 7 tripled, which is 21. The new base is going to be 2 doubled, which is 4. So our new area here is going to be 21 times 4. Oh, whoa. My bad. That's not actually going to give us a triangle that works. Okay, so let's say if we want 14 here, we'd have to go with a width of 4. Okay, so let's see here. The original area, which is what I should have done first of all, is going to be 7 times 4 divided by 2. 7 times 4 is 28. 28 divided by 2, 14. There we go. Okay, so now we can take our height, which is 7. We're going to triple it. We get 21. Our base is 4. We're going to double it, and we get the new base is 8. So this new triangle, it's going to have a height of 21 and a base of 8 because the height has tripled and the base has doubled. And now our new area is going to be 21 times 8 divided by 2. 8 divided by 2 is 4. 21 times 4 is 84 centimeters. And if we take 14, our original one, let's do it up here, 14 times 6, we get 84. So you can see that it does work out here. Jackson, you may have had a different set of distances here, but hopefully that's close enough to what you did that you can get a sense of it. I'm not hearing much from other folks, so please jump in. You're kind of letting Jackson do the hard work right now of chasing down what things are making sense and what things aren't, and I'd like to help all of you out. So please let me know what questions you have about this, and it can even just be as simple as, hey, can you show that again? I didn't follow it. It doesn't have to be a really specific question, although certainly great if you do have specific questions. If you don't have any questions and the clarifications that Jackson got there have solved it for you, let me know by putting a 1 in the chat. Okay. Request to show that again. Absolutely, Alan. I'm going to pick a bit of a different one maybe so that you get some different examples of how this looks. So, Alan, let's scroll back and take a look at your triangle. You had 6 by 11, base of 6, height of 11. So we have a base of 6. We have a height of 11. I've been mostly doing isosceles triangles. There's no reason it would have to be like that. So the area for the original triangle is going to be 11 times 6 over 2, which is 33. And that's what Alan told us earlier in the chat there. If you scroll up, you can see it. So the new base, or let's start with the height. So the new height, well, the height tripled. So it used to be 11, but now it's tripled. So the new height is going to be 33. The new base, well, the old base was 6 and it doubled. So the new base is going to be 12. And that means that our new area for this much larger triangle is going to be the height times the base divided by 2. 12 divided by 2 is 6. 33 times 6. Calculating 198. And we can see that the old area was 36, and 33 times 6 is indeed 198. We know that because it also happened to be what we had to do for the formula there. All right. So what questions do you have? Alan, is that making a bit more sense now? Okay. So the point I want to reinforce about this is here we did it kind of the long way. Cool. Thanks, Alan. So we went back, we said, okay, we've got the original area. Let's calculate the actual value of the new height. It's 33. Let's calculate the actual value of the new base. It's 12. Let's take the base times the height divided by 2 and get the new area. So we've gone through and we've done the entire calculation. But the thing I'd like you to learn from this lesson is that if the old area is 33 and we know that the height is tripling and the base is doubling, instead of calculating the new height and the new base and then redoing the area calculation, we can just say, take the old area. If the height triples, that triples it. And then you take that, and since the base doubled, you need to double it. So I can just take the old area times 3 times 2, and that will give me the new area. So the old area was 33 times 3 times 2 is indeed 198 as well. So we now have a much faster way to calculate this new area. We don't have to go through and get the new height and the new base. We can just take the old area, triple it, and then take the answer of that, double it. And of course, if you triple something and then double it, that's like multiplying it by 6, right? If I take this shape and I triple it, 1, 2, 3, and then I double that, I'm going to get 6 of them. All right. So I'm going to leave it to you to try out from question 12 onwards. I'm going to give you a little bit, I don't want to call it a warning, but just be aware. For perimeter, things are not nice. I'm going to write that, and you can write that as well. You can put it, where's the first perimeter? So question 14 is where it starts asking about perimeter. So for perimeter, it's not so nice. All right, if you take a rectangle and you double the length, the perimeter does not double. In fact, there's no like nice factor that the perimeter always changes by. Depending on how long and how wide your original rectangle was, your perimeter might get 1.5 times as big, or 1.25 times as big, or 1.6 times as big, or almost any other number. Right? There's a lot of different options for what can happen. There are some situations that are nice. So in a circle, for example, because radius is the only thing that's affecting the perimeter, if you double the radius, you do get a nice, consistent result happening with the perimeter. All right. So for perimeter, it's not so nice, really, except circles. But area is nice no matter what shape. So we've seen it here with rectangles. We've seen it with triangles. We've seen it with circles. This is true for any shape. All right. If you have like a cookie cutter design of a gingerbread person or something like that, if you doubled the height of the gingerbread person and you didn't change its width at all, then you're going to get a doubling in the area. If you double the height and you double the width of this gingerbread person, then you will get a quadrupling. So times 2 and then times 2 again for the area. So doesn't matter what shape it is, area always nice. But for perimeter, generally not nice, except circles. Or if you change all the dimensions of a shape by the same amount. So if you have a triangle and you double the width and you double the height, you'll always get a nice result for perimeter. But if one dimension changes differently than the other, perimeter is not going to work out super nice. So I'll let you go through and try it out. Jackson, we just said a couple of things about perimeter. I'm going to let you work through them and try them out in the handout as your homework. But the one thing I did say about perimeter is it's not like area, where area we get things working out nicely. If you double the length, the area doubles. If you triple the height, the area triples. If you double the length and triple the height, the area is going to multiply by 2 times 3, which is 6. So for area, super nice. Doesn't matter any shape. For perimeter, not so nice. You won't be able to get a consistent rule most of the time. The exception is for circles, or any time all of the dimensions of the shape are changing by the same amount. If they all double, then you'll get a nice rule for what happens with the perimeter. But if one of them doubles and one of them quadruples, all of a sudden you're out of luck. All right. So I hope that helps. Feel free to ask me questions as you're going along through. My grade 12s did a test last week and over the weekend. So for the last couple of days, I've been doing a lot of marking on that and not being as quick with email responses. I'm going to try to do a better job being quick to respond to your emails over the next couple of days. So look forward to that. Take good care, everybody. Stay safe. If you have any questions, please let me know. Have a great rest of your day.